one of the last talk of AppSec. There's still the closure. My name is Luca Compagna. I'm working for the product security research at SAP. And what I'm going to talk about is a joint work with many partners. Some of the people that have been working are in this room also. And it's about the SPaCIoS Tool. It is a research prototype that we have built over the last 3 years. It's still a prototype, and I mean, we are still working on this. It's a combination of different techniques. I don't know if you can read through it, but basically you have model checking inside, security testing, some penetration testing approaches that we have developed, model inference, many of these approaches, and the ultimate goal is to help the security analyst, so perhaps some of you, to test a system under validation. And I'm not going to present the entire architecture. I will just walk through some usage of this tool, and I hope I will show you more or less the global picture. Before doing that, there are many tools around to help security analysts, and our purpose was not to, let's say, to provide a tool that is substituting to all the others, is going better on everything or whatsoever. Our purpose was really to try to explore complementary approaches that are not part of the tools that are already in the state of the art, and to see how these approaches perform on certain use cases from industry, so real use cases. And we have done it with in mind a few requirements. We wanted to be rigorous in our approaches, formal. We wanted our approaches to be automated as much as we can. Also because automation could also be a trouble. I mean, some security analyst might want to exploit this knowledge on the domain and doesn't want to have a tool that is completely automated, actually. So it can even be a drawback to some extent. And in doing so, we wanted to combine different techniques developed by different partners that have, let's say, expertise on a certain domain. So who better than this partner can create that technique? And then we just combine these techniques together. And in doing so, something that was really important for us was to capture the logic flow of the system under validation. So anytime we do testing, we do that by exploiting, first of all, by capturing the logic flow of the system under validation, and then by exploiting this information to hopefully discovering some vulnerability that others were not able to discover. And we focused on mainly two domains: security protocols that are established security protocol from security standards like SAML single sign-on, OAuth2, OpenID, and also on web application for benchmarking like WebGoat, but also on real one for shopping cart, and we have also application from some of our partners, Siemens, that had some real industrial case that wanted to validate with our techniques. And here it's not supposed to be read at the moment. We will go into that later on, but it's just to show you, to anticipate that in doing so, we were able to have quite a good coverage with respect to the OWASP top 10. I mean, it doesn't mean that we do everything about broken authentication and session management, but we were able to exploit the logic of our system under validation in order to show that there were some authentication flow or some breach of data confidentiality here and there, and this is what we were doing for this specific OWASP top 10. Besides, we have two industrial partners involved in this initiative, SAP and Siemens, and we were always trying to take results from research, so with academic partner, and to exploit these results through transferring in our respective company. And I will tell you something more about that by telling you some of these stories. So, the SPaCIoS tool and what you can do with it. Let's take a first use case, and here we focus on what are the desiderata of the system under validation. So I have a system under validation, and I want this system to satisfy, to enjoy certain properties, like I want these two entities to be mutually authenticated. So this is an example of a property that I want. And to be more concrete, let's consider a real business case. Let's imagine that there is a company, SAP, that wants to integrate in his product our product, some security standards. Okay, SAML single sign-on. So SAP wants to have its product speak in SAML. And for those of you that do not know, SAML single sign-on is the protocol that is here. You have a client that wants to get a service, some resource from a service provider, and the service provider basically authenticate this client through an identity provider. And there is a specific flow of the protocol that should satisfy this property. So at the end of the protocol, the resource that is provided back to the client from the service provider should be confidential. And the service provider should be sure that he's talking with this guy, C. These are the two desiderata, the two properties that we want. But besides that, when the development team has to implement this solution inside the SAP product, it will read through bulky specifications. You will have to interpret all these specifications. The specification is is presenting you a lot of options, because at the end of the day, the security standards wants to be usable in multiple environments. So you can imagine it's highly configurable. You can also imagine that the company itself might have its own internal requirements that perhaps do not match completely what is written in the standard. So perhaps the company needs to do some deviation from the standard. And all in all, the question that these guys can have is, what are the consequences from a security point of view? So can I have a tool that helps me to answer some of these questions here? The guys in our development unit were saying, for instance, we do not understand why the service provider generate these specific nonce here. We're not going into the details, but just to give you an instance of the problem. This ID, and why he has to check this ID in the response later on. For us, it doesn't seem to be necessary. Actually, it's even a problem, because by doing that, I need to store the ID at this moment when the client is not yet authenticated, and that can be a vehicle for denial of service. So can I get rid of that recommendation of the standard? And what do we do? So what our tool proposes in that respect? So you can see here the property that I was mentioning before, the confidentiality of a certain data, authentication. And here is what we do. So we create a model representing, capturing the SAML single sign-on protocol. So capturing the message exchange between the different entities that are involved in the protocol. And in this model, we capture the assumption that we have. So we can imagine we have done a model in which there is this ID, and the service provider is checking the ID, and we have done a model where the service provider is not checking this ID. And we were checking whether one of the properties that we wanted was violated or not. And how we do that? We do that through model checking. So this is a well-known technique, is widely used in the security protocol community, especially at the research side. I can't say the same for industry, but maybe we will reach that point. How does it work? Basically, it takes in input this model with the properties, and takes some time, and eventually you will get some attack trace. Attack trace that are in an abstract form. I will show you what I mean in a second. So here is an example of a model. We are in the Eclipse environment here. SPaCIoS Tool is provided as a set of Eclipse plugin. And here is an example of specification. Each one of the entity of the protocol is specified as a kind of process. So here I'm specifying the entity service provider. Without going too much into the details, you can see here there is a body. The body is what the service provider is supposed to do. And at the beginning, he is expecting a message from an entity called C. This message has to go on a certain channel, and this message is for himself. Actor is what in Java is this element. So it's kind of a pseudo programming language, if you like. And here I'm saying, okay, the message that I expect is of this form, is an HTTP request of method get, and there should be a certain URI. Then, as soon as I get this message, I create a fresh number, and I send back to C on a different channel a response that has something inside. And basically, this is what you specify at the modeling level. And now what, with the SPaCIoS tool, what you can do is you can go here and you can press a button and you can run the model checker. I will not do that because it will take more time than this presentation requires, so I don't think we want to wait for the model checker to provide the answer. However, what is important, I mean, for you, might seem trivial to have just a button, but for somebody like me that worked in this area for many years, you can't imagine the frustration of not having that button. When you have to go on command line and you have to run with all different parameters, etc. So for me, this is a great achievement. I'm not sure I can transmit convey this feeling to you. Let me go back, and now let's imagine I have run the model checker. What he would have discovered is something like this. And you can see it's a pretty abstract syntax. It's not so easy to read, but fortunately we have created a way to better read through it. I mean, I'm sorry, the resolution is not the best, so I can't show you the entire trace here, but you can imagine this is a trace violating one of the property. Okay? I will not go into the details, but very good. Now we have a trace. And so what? Is the real system really affected by that trace? By that abstract trace, yes or no? And what we do is basically we transform this abstract attack trace in a set of HTTP requests and the HTTP response for the system under validation to check whether the system under validation really suffered from that vulnerability. And to do that, of course, I need to provide some information. I need to provide the test data. I need to say where is I don't know, the Google Calendar, if that is the resource that I want to try to access. And going back to the demo, this is how we specify those information for Google. Actually, this is the use case is Google. So for instance, I'm saying that the identity provider is at this URL, that the service provider, so the one providing resources, is at this other URL. I have to provide also some, let's say, way to create, to transform that abstract symbol HTTP request in a real HTTP request. So this is a code that you can imagine there is a library already there that user can simply use. And now once I have this, I have to say who I want to test. So I want to test the service provider and the identity provider of the protocol, or I might decide that I want to test only the service provider. So basically these are the entities that will not be simulated by our testing environment, but will be probed by our testing environment. And now I can run the test. 10 minutes, okay. So I really need to speed up. And if I run the test, you should see at some point the console opening. Yeah, it's here. And here basically that abstract trace is transformed in this HTTP request, and at some point we should get a message. So here is saying success, meaning that Google suffered from that vulnerability. And now, I mean, you can see what was going on. Basically is that there was a client asking for a resource and he was getting something else back. I will not go into the details of these, but you can look the details yourself if you are interested by reading through the paper. So I leave you with the idea that Google might have this vulnerability, but let me just say that it's not a very serious vulnerability. Okay, we discussed with them, and there were mitigation actions that were taken. Let me go back to the presentation and let me speed up. So I think I will skip this. The second use case, if I have time, I will come back to this. Let me take another usage of the SPaCIoS tool. So let's imagine now that the model checker doesn't provide any trace. So it's telling me nothing, basically. It looks like the model is secure, okay? So now I'm really sure that the implementation is secure. Maybe the developer has done some mistakes in developing. So how can I check now that? Well, what we have done is to create what is called mutation operation. Each mutation operator captures one of these development mistakes. The mutation operator goes in this engine where also the model come, and basically the model is mutated, and then the model checker run again. And eventually now, you will get an attack trace that might be a false positive, because maybe the implementation doesn't suffer for it. But what is the best way to be sure of that is just to concretize again and to run on the system under validation. I would have a demo, but I think I have to skip that, otherwise you would not see the other usage of the tool. Let me move to another use case that I would like to show you, because so far we have focused on the properties, so what I want the system to achieve. What about all the vulnerabilities that we all know? Cross-site scripting, cross-site request forgery. I mean, the attacker has very precise strategies in order to execute this kind of attacks. So we decided to basically to not write the formal models, to run the model checker here, but we decided to go for attack patterns model, so a way to model the attacker behavior with instantiation file that represent the payloads, the possible payloads that the system under validation might answer in some strange way if probed with those payloads. And just to give you an example, here is, it's not very good in this resolution, sorry, but this is a way to test file enumeration, okay? So this small system with few states and few edges, is just a graph, is sufficient to test file enumeration on a bunch of applications, including web code. And how does it work? Well, basically, this is just a state, and when I move from this state to this other, here I have some guards that I have to satisfy, and I can specify which are the conditions in order to fire this action. I have some input and output, so messages that I can expect, a message that I can send once the guard is satisfied. And by doing that, I can basically use, let's say here is various strings that you can use for file enumeration, and I can just specify the configuration for webgoat, so where is the webgoat link, and I can run this test on webgoat to see what is going on. And actually, we were able to succeed in some of the lesson of web code in that, but this was also used at Siemens. We had other use cases. I will just mention them. I will not go into the details. Evolutionary fuzzing for filter type 1 and type 2 cross-site scripting. We were able to discover some vulnerability here that other scanners were not able to discover, because these other scanners are not considered in the logic flow of the system. I invite you to go into the details in the paper of Fabien to see what are the technical details here. And another approach we put in place is based on what we call business logic patterns. So we were applying this to shopping cart, and we were trying to figure out which are the business logic pattern that an attacker might try to violate in order to do something nasty with the application. For instance, you can imagine that when you have a coupon and you want to pay something with that coupon, the web application, the shopping cart application, should not allow you to use this coupon more than once. So that is a kind of pattern, business logic pattern, that the attacker might try to violate. So we do automatically an analysis of the web application through some traces, network traces. We figure out the model, and then we apply systematically this pattern, and we were able to discover, to shop for free in a bunch of application. And again, for this, the paper is not yet there, but it will be published soon, I hope. So you will have to wait a little bit. So all in all, I think we got some promising results. Here is again the table you have seen before. And besides protocols, benchmarking application, Siemens was using a lot these techniques to validate their info-based e-health solution for the web. And we, at SAP, for instance, we were using this technology to check our internal implementation of SAML, OAuth, and others. And Just to provide few highlights in that work on SAML single sign-on, in the end, for this authentication flow, we got a SAML errata from the standardization body. So I mentioned already we are able to find some type 1 and type 2 cross-site scripting that others were not able to find. Shopping for free, this will be published, and we have some transfer at Siemens that is going on. And with this, I've finished. Just keep in mind that the tool is not yet available for you, but it will be end of January. So if some of you is willing to give it a try, well, if some of you is willing to give it a try already now, you can contact us. We can give the tool as it is, but probably there will be more bugs that you might expect in January. Otherwise, January 2014 will be available. Thanks.
So thank you very much for the talk. That was very nice. Are there any questions? We have plenty of time for questions.
So the last time I worked with model checking, I remember you always get into state explosion problems when the model gets too big. Had you the same problems with your approach, and do you think you can cover it when you want to verify larger models?
Yes, that is the case. So indeed, when you write the model, you have to be very cautious in, let's say, putting in there what is really relevant. So writing the model is one of the challenges that we have. And it's nice that you ask me, because you give me the possibility to go back, if I can. Good. So just to mention that we had thought about also creating the model automatically. So imagine that, I mean, not imagine, but when you talk with developers, especially, this happened to me, I go to SAP developer and I say, okay, you can use these techniques. Okay, I have to write a formal model. I don't know how to do it. Or, well, I couldn't even learn how to do it, but I don't want to do it. So what can we do to help these people? And we were thinking to a bunch of techniques. The first one is a black box model inference. So you start testing the system under validation, and you try to create automatically the model. In that case, you don't have a model that is big. You have a model that is pretty small. The challenge is, do you have enough information in the model to find out something relevant? You can always kind of imagine that you create this model in this way, and then you add something manually, and you go in this iterative approach. But something else that you can do is a white box model inference. So you take the code of the system under testing, and you try to infer the model. And here is the opposite situation. So normally the model is huge, and so you have to be very careful in what you put in there, because if you put too much, then you will not have answer in reasonable time from the model checker. And something else that might be promising, we haven't done it yet, so is what if we just ask the developer to write sequence diagrams or some UML diagrams they might be, let's say, familiar with and willing to do it. Actually, they do it. When before implementing anything, they need to have some use case, and they write something like that. So, and this, I believe, can provide a model that has the right level of information, especially for protocols, but we can see also for web application if we can do something like that. And last thing that could be of interest for the model is the network traces. So what if we have just collect some network traces? There is just already a work about that from colleagues. Outscan is called. You create the model automatically from the network traces that you can collect by playing a little bit with the system under validation. In this case, again, the model should have reasonable size, because but definitely you touch an important point. So model checker is a very complex, so from a timing point of view can be problematic performance. Yes.
Thank you.
You're welcome.
My question is about this tool and when it will become available in 2013. Is it going to be an OWASP tool freely available? Because we mentioned Siemens, and I understand the research was done for Siemens, but obviously we're an open community here. Is it going to be released into community?
Okay. It's a good question. We haven't thought about that. It's not an OWASP project. At least it is not at the moment. What we are doing is we are trying to have all our components open source. This is something that I think will happen. You have to imagine that it's a big consortium of partners. So you see the partners, and there are two industrial players. So it's not always easy to go. I mean, it takes some time to go along this process for open source. But I think it will be open source. That from there to become an OWASP project, maybe the distance is not so big. I don't know. It could be an idea. At the moment, it's not. It's just a research prototype.
Thank you very much for the awesome talk. There is a model checker I'm aware of at least 7 years, OWASP.
Yeah.
And there is the descriptive language, HLPSL. So I wanted to ask you, can you make a correlation to this project? Because it is not, let's say, I'm not aware of that someone can write the description of the protocol automatically, so it is manually set up. Still, I know about it. Let's say the designer should set up manually the protocol and test it after that. So with the different checkers. But can you make a comparison between the OWASP and your model checker? Thank you very much.
It's pretty easy because the people that are working on this project were working on OWASP as well. So basically, this is the continuation of OWASP, actually, the language is not so the formal language that we are using is not so different. It's an extension of the AppSec that we were using. I think is a bit stronger now, and also the semantics is a bit better. I mean, so what we are doing here could be done also for the AppSec++, the OWASP level. Let's say.
Okay, we still have one more, so we have time for one more question. Are there any more questions? Okay, then thanks to the speaker again.